So finally, we look at what is a resistance. So we can define resistance as the opposing force to the flow of current through a closed loop circuit. So previously we described a circuit having a form like this, which is a closed loop circuit. When there is a closed loop circuit, we know that there is a flow of electric current through this circuit. So it must always be connected to positive and negative in order for the current to flow. So for example, if we look at conventional current, a flow of current from positive to negative. So we all know that when there is the opposing force, that means there won't be enough current passing through the circuit. So this is the result of what is known as the resistance. So imagine that you have a pipe like this. So we have those streamlines which represent the flow of, for example, a water. So in that case, if this region is small, that means it represents the resistance of the water, same as for the resistance in an electric circuit. So when water pass through, it will find it a bit hard to pass over to the other side. So in that case, if there is a flow of water towards this region of the resistance or a hollow tube, then what will happen? The resistance will decrease. That means the flow of water will also decrease. So it will not have the same amount of the flow from maybe point A to point B. So in that case, we can say there is a decrease in the resistance. So that means it is the opposing force to the flow of current. So that means if we have higher the resistance, that means it will restrict most of the flow of current in a material or in a closed loop circuit. So in that case, the resistance of the wire, it is also can be measured in terms of the length, the cross-sectional area, and the temperature of this particular material, which describe its resistance. So in that case, let's look at an example of a resistance. So for example, if this region, let's see if this region is made up of high resistive material. That means we have the length and the cross-sectional area and the temperature. But to do with the cross-sectional area, if we say that the cross-sectional area is very, very small, what will happen? So imagine in terms of the light bulb. We have the symbol for the light bulb, which is like this. So this case, we can see that the cross-sectional area of this light bulb is very, very small. So that means when there is current passing through this small area, if the required amount of current, which is quite higher than the resistance, that means it will force current to pass through this region. And in that case, since there is small cross-sectional area, this filament, or we call this copper carrying wire, will becomes very hot. So in this process, it will what? Glow. And then it will produce what is known as the light. So this is the basic understanding of a resistance. Since this region has a very high resistance, and when there is more current passing through it will becomes very hot, and in that process it will produce what is known as the light. So we can have a light here which has a specific resistance, and it will glow according to the flow of current. So that means in terms of this region, in terms of the flow using the Bernoulli's flow, that means this region will have a higher pressure. So in the light, in with respect to this resistance of a copper wire, it will becomes very hot. So high pressure with respect to very hot when there is more current passing through a small cross-sectional area. So this is very important. And this is the work of the resistance. So now we'll try to look at an example which will give us a general understanding of what is a voltage, a current, and a resistance. So imagine there is a person. There is a person on the field. So we can say this is a field and he is playing a game of soccer. So this is a soccer ball, and maybe this is a goal post. So with location A and location B, so we can see from this person, we can say this person is nothing but a voltage. So the voltage is the person, and then we have the current. So the current is nothing but the ball. And then we have point A and point B, which might represent a conductor. So in between, so in order to pass the ball from point A to point B, this ball cannot pass from point A to point B unless there is a force applied. So that means if the person is kicking this ball, that means that the ball will flow from one point to another. So that means without this person, the ball cannot move. So in that case, the person is applying a force to the ball, and then the ball will flow from point A to point B. But in between, for example, there is a crosswind which will act as a resistance to the ball being kicked. So in that case, this particular wind can be known as the resistance. So if the wind is so strong, that means it will take huge amount of force to pass the ball from point A to point B. So that means in this scenario, we can see that in order to pass the ball from one place to another, we need some kind of force. So this force is there in order to make the work done by transferring the ball to point A to point B. So once the ball is passed from point A to point B, we can say that work is done. But in between, there are some circumstances such as the resistance. If higher the resistance, that means it will take time and more amount of force to pass the ball from point A to point B. So I believe with this small scenario, you can be able to fully understand what is a voltage, what is a current, and what is a resistance. So with all of this, they all play an important role in an electrical circuit. So this video series is all about understanding what is a voltage, current, and resistance. So thank you for watching our video, and if you like what we are doing, you can kindly like and subscribe for more future video.